So the challenges what I'm going to explain, 30 challenges. If you try every day, whatever challenge I am going to give, if you try every day, at the end of the 1 month, almost you are okay with the DSA lectures. Right? Let's see the first challenge. Given a linked list, swap every two adjacent nodes and returns its head. You must solve the problem without modifying the values in the list nodes. That is, only node themselves may be changed. Yeah, I think many people got it. Many people got it. If you are not, so I think some input also given. Let me explain once. Let me explain once. It is a linked list. It is a linked list. Let me explain the problem first. It is a linked list. Yeah. So this is the linked list. It is a head. So in this linked list, what you have to do is you should write a program. You should write a program to swap every two nodes. To swap every two nodes. To swap every two nodes. Every two adjacent nodes. To swap every two adjacent nodes. I think it will be after completion of the program. It should look like this. So it should be 2000. It should be 1000. So this is going to be, I think, nothing. You no need to change any data inside the node. So it will be B only. It will be A. Right? So, but previously it is the 2000. Now it is 1000. Right? Fine. Previously A next is 2000. Now it should be go to 3000. Right? Let's see. So let's swap the next two nodes. It is a 4000. It is a 3000. Right? This is going to be D. This is going to be C. This is going to be 3000. This is going to be 6000. It's going to be 5000. It's going to be F. It's going to be E. It's going to be 5000. It's going to be null. Right? I think it's going to be 6000. It's going to be 4000. Every two nodes you have to swap. Remember, nodes only you have to swap, not the data. Not the data. So I done the swap. So for the resultant linked list, it is a head. So you should write the program for this. Every day I will give one challenge, and the previous day problem I will give answer. So today is the first day I given the problem, right? So what I want is you try first. You try to write the program, whatever language you like. Whatever language you like, you can write. Language doesn't matter. Whatever language you want, you can write. Right? At the end of the program, please find out time complexity also. And you may say that lastly two nodes are not there, only one node, keep as it is. Suppose isn't that number of nodes are odd number of nodes, so one node is left out, keep as it is. Every two nodes you have to swap. Right? Maybe you can take one while loop or one for loop, manage properly. You should write the program for this. You have to say what is the time complexity. Right? Given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes. Only nodes themselves may be changed. That is a given problem. That is a given problem. So let me check one time. So I think I took right, this one. See, First to two nodes you have to swap. Next to two nodes you have to swap. Nodes only, not data. Next to two nodes you have to swap. Next to two nodes you have to swap. And one more important thing is, if only one node is there, there's nothing to do. No node is there, you can stop. One node is there, same answer. If only one node, what will you swap? So every two nodes you have to swap. Every two nodes you have to swap. And one more thing, right? First node, right, is given as a head. It is a head. First node is head. If I ask you print head, right, 1000 will be printed. Every node having address. Print head 1000. Print head next to 2000. Head data A will be printed. If I say print head data A will be printed. Print head next to 2k will be printed. Print head, so 1k will be printed. If I ask you print head, 1k will be printed. 1k means 1000, some address. Next one, if I ask you print head next to, then 2k will be printed. Next one is the print head data. Head arrow data. A will be printed. So remember this. Right now I am starting the answer for this. Every two nodes you have to swap. Suppose isn't that no node is there, simply return. One node is there, simply return. Right? Fine. So I'm starting, everything is fine now. Everything is fine now. I'm writing the program for this. Let us assume that function name is, swap two nodes. Function name is swap two nodes. To this function input is a head. But the head is the address. So star. Which type? Let us assume that like integer, character, float, some type is there. So I am keeping the type as node. Right? Head is a address. So star. Which type of address? Node. Let us assume that some type is node. Swap two nodes of linked list head. Linked list given means head given. Head is the address. So star operator. So address of which type? Assume that node type. So go inside. See everyone now. If head is equal to null, means if no node is there, R operator. If you want, you can use R like this. Next one, head next to is equal to null. That means one node. So remember, if no node is there or one node is there, answer is itself. I cannot do anything. Return head. I cannot do anything. Right? This is the first step. In every linked list problem, this is the first condition which you have to write. In every linked list problem, first condition mostly something like this. Sometimes 0 nodes, sometimes 1 node, sometimes 2 nodes also. Head is equal to null or head next is equal to null, return head, because 0 nodes, what I will swap? 1 node, what I will swap? Suppose this condition is fail, means there, right? I think more than 1 node is there, we can do something. See what I am doing. Everyone listen, see what I am doing. Everyone observe. I am taking one variable. New node is you. That variable name is new node. New node is equal to head next. So it is a new node. If anyone having doubt, it is a new node. This is the new node. This is the new node. Right? Next one. I written the shortcut NN. Next one. Temp is equal to head next. Don't bother about the syntax semantics. Just see the logic. So this is temp. You may say that, sir, why you kept a temporary variable here? So sorry, this is the temp. Sorry for this. It is a new node. Right? New node is equal to head next. Next one, temp is equal to head next. It is the temp. It is a temp. So let me remove unnecessary part. If anyone is confused because of me, so I am rewriting again. I am rewriting again. This is new node. This is new node. This is temp. You may say that, sir, why temp, sir? If you swap these two people, further connection purpose, further connection, temp required. Second node is the new node, right? So next one is going to be after two nodes, next two nodes, first person is temp. So in the first group, first person is a head. In the second group, first person is a head. Right? In the first group, second person is new node. So everything is perfect. Everything is perfect. Let us assume. Right? I think until now everyone is comfortable. Let us assume everyone is comfortable. Now see what I am doing. Now see everyone. Everyone observe what I am doing. Everyone observe what I am doing. See this one. New node next is equal to head. That is the meaning of swapping. I am swapping first two nodes. So I think let me remove unnecessary part. So this one. New node next to this one is equal to head. Head means what? 1K. I kept 1K. That means he will point here. That means he will point here. You don't point further. Some students are saying, sir, if you don't point further, how can you go? Temp is there. Temp will take care. So new node next is equal to head. Then you may say that, sir, what about head next, sir? Head next should point to something like a temp. Right? So let us assume that. Everyone listen. Let us assume that using the recursion, I will give this answer. Assume that using the recursion, I will swap these people also. It finally returns some address. Some address assume. Using a recursion, I will complete these people swapping also. It is finally returning some address. Assume. Now see the answer. Now see the answer. Head next is equal to swap two nodes. It is a recursion. Swap two nodes from temp. So from temp onwards, I will swap. It returns some address. To that address, head next will point. So remember, initially head is here, new node is here, right? Head is pointing like this, right? New node is pointing like this. Now what I done is, I remove this one. So what I done is, this is the A person, this is the B person. So you want to swap. Then what happened? B next is equal to A. So B came to here. But A next is equal to this is the area where recursion will take care. So AB becomes BA. So this recursion will take care about the remaining people. Yes, it is taken care. So lastly, let us assume that A, B, C, D. So here also reverse happened. D here, C here. So he will do like this. His address. Assume that, right? Approximately his address is, I think, 4,000. So here 4,000 will come. Right? So this address is everyone know. It is a 2,000 person. I think it is going to be 1,000 person. Right? 2,000 person. It is a 1,000 person. So 1,000 next is 4,000. So like that it is happening. Lastly, return new node. Return new node. Because modified linked list first person is going to be new node only. So this person. So he came to here. This person next will goes to. This person next will goes to. This person next will goes to in this area. In this area, whoever first person. Like that it is going. This loop is keep on going. So let me end this story. So end of the story. It is a recursion. If you don't want recursion, you can take one while loop also. You can take one for loop also. For every two nodes, you will do like that. For every two nodes, you will do like this. And one more thing is, I think every 2 nodes is keep on doing. I think it will take maximum 1 loop kind of thing. Order of n time. Time complexity, order of n. One scan required. So first to two, right? First to two people apply this code. Second to two people apply this code. Third two people apply this code. Fourth two people apply this code, and so on. Everywhere applying this code. This code is actually constant, but you are applying this code again and again, almost like for all the nodes, right? So time complexity order of n. Every round is constant, like that you are doing almost like n by 2 rounds, right? Almost like time complex order of n. Space complexity, other than some local variables, I have not taken anything. So extra space. Space complexity means extra space. Extra space is constant. Extra space constant, other than some local variable. See, new is a local variable. New is a local variable. Temp is a local variable. Except 1 or 2 variables, I am not taken anything. Except 1 or 2 variable, I am not done anything. So time complexity is almost like one scan order of n. Extra space is order of 1. And if anyone having small confusion also, if you have small confusion also, right, you can see one time. You can see one time what exactly I done. What exactly I done, you can see one time. What exactly I done, you can see one time. Right? So recursion will take care. See, these people will talk afterwards. These people will talk afterwards. Let us assume that it is a 3000. Let us assume that it is a 4000. It is a 5000. It is a 6000. Assume that. It is a 1000. It is a 2000. It is a A. It is a B. See what he done. Exactly observe what he done. First two people you have to spare. So this is head. This is new node. So this is temp. 3 people he kept like this. Head, new node, and temp. Now what he done is in the story what he done is, right? So new node next is head. New node next is head. So let's see this. This will become like this. New node is this one, right? 2000. Is next is head. He done like this. Okay, you done like that. Afterwards, this is the new node, this is the head. Head next is equal to this area. This area also they will do swap. Recursion, it will take care. Don't worry about the recursion. Recursion, whatever you doing in the starting, further also same. Let us assume that it is a C, it is a D. Same thing you will repeat, same thing you will repeat. Then what you will repeat now? Let's concentrate this. So here D will come. Address is 4000. Here C will come. Address is 3000. So he will point like this. He will take care further story. Further story he will take care. This address 4000 he will return. It became 4K. It became 1K. Like that every two going on. Every two going on like this. Every two going on. Every two people constant time. Every two people swapping constant time. Like that approximately we are doing for all the people. So time complexity became order of n. Other than some local variable, you are not taking anything. So time complexity becomes, right, order of n. Space complexity, extra space become constant. Remember, lastly you are returning new node. New node is the address. So star. Which type? If you want, you can write the type as node. Node type pointer. So here I written the node. So every person is node type. You may say that, sir, some local variables you are taken. If you want, you can declare those also. Let me write. Node type, few people I am taken. New node I am taken. Node type people, new node I am taken. Temp also I am taken. They are also pointers. That's it. So this is the program for this. The first challenge, I written the program also. I explained also. First program, right? First challenge, whatever I given, I explained the problem. I explained the answer also. I explained time complexity. I explained the space complexity also.